Hello students, today I am going to discuss Cambridge A level May-June 2023 paper 22. First question number 1. The melting point of some solids are given in this table: magnesium, phosphorus, sodium, chloride, sulfur. A1. State the type of bonding present in magnesium and sodium chloride. So magnesium is a metal, so metallic bond. Sodium chloride is an ionic compound, so ionic bond. Number 2. Explain the differences in melting points of magnesium and sodium chloride. Sodium chloride is ionic compound, so bonds in sodium chloride are stronger than bonds in magnesium. Ionic compound, there is strong attraction between opposite ions. Three. Explain the difference in melting points of phosphorus and sulfur in terms of structure and bonding. Sulfur exists as eight atoms joined together, and phosphorus exists as P4. So sulfur has more electrons. That's why sulfur has stronger induced dipole forces, IDID forces, because sulfur 8 has more electrons. So more induced dipole forces. B1. Define the term electronegativity. It is the power of an atom to attract the electrons to itself. This means, say, hydrogen chloride. Chlorine is more electronegative than hydrogen. So electronegativity means it is the power to attract the shared pair of electrons of an atom in a covalent bond. It is the capacity to attract the shared pair of electrons, bonding electrons of an atom in a molecule. B2. Explain why electronegativity increases across a period, left to right. Across a period from periodic table left to right, nuclear charge increases. So increases in nuclear attraction for the outer electrons. That means periodic table from left to right, nuclear power increases, so nuclear attract electron more strongly. Three. Name the strongest intermolecular force that exists between ammonia molecules. This is hydrogen bond or hydrogen bonding. The molecules which have NOF, nitrogen, oxygen and fluorine, these molecules have hydrogen bonding. What is hydrogen bonding? The attraction between partially positive hydrogen of one molecule and partially negative oxygen, nitrogen or fluorine of another molecule is called hydrogen bonding. 4. Draw a diagram to show the formation of strongest intermolecular forces between two molecules of ammonia liquid. That means ammonia has hydrogen bonding, so one NH3 molecule, another NH3 molecule. Between two molecules hydrogen bonding is formed. This dotted line is known as hydrogen bond. I mean the delta plus hydrogen, delta plus means partially positive hydrogen of one ammonia molecule attract the partially negative nitrogen of another ammonia molecule. This intermolecular force is the strongest and its name is hydrogen bond. Number 5, the melting point of ice and ammonia are shown in this table. Ice melting point 273 and ammonia 195. Ice, you know, water solid, and ammonia is NH3. So ammonia and water molecule both can form hydrogen bonds, but ice melting point is larger than ammonia. Now question is asking, suggest two reasons for the difference in the melting point of ice and ammonia. So oxygen, you know, oxygen is more electronegative than nitrogen. Oxygen atom is more electronegative than nitrogen atom. So per water molecule 2 hydrogen bond is formed, and per ammonia molecule 1 hydrogen bond is formed. That means ice more hydrogen bond is formed. As more hydrogen bond is formed, so to break more hydrogen bonds more energy is needed. That's why melting point is higher. Come to next question. Question number 2. Chlorine is a reactive element. It forms many compounds. Complete this table to show the maximum oxidation number of elements sodium to phosphorus in their chlorides. I mean sodium chloride, magnesium chloride, aluminum chloride. So this element maximum oxidation number, sodium is a group 1, so this plus 1. Magnesium group 2 plus 2, aluminum is group 3 plus 3, silicon group 4 plus 4, phosphorus 5 plus 5. They are chlorides, say PCl5. That means phosphorus, chlorine is 5 chlorine, negative 5, so phosphorus is plus 5. Number 2, state what determines the maximum oxidation number of element in period 3. Maximum oxidation number determine the number of outer electrons or valence electrons. Maximum oxidation number shows how many electrons are there in its outer shell. Now number B, an excess of cold water is added to the chloride of silicon. Chloride of silicon means silicon tetrachloride. Write an equation for the reaction between an excess cold water and chloride of silicon. This not HCl, water. H2O. Silicon tetrachloride reacts with water to form phosphoric acid and hydrogen chloride. Question B1. Write an equation for the reaction between an excess cold water and chloride of silicon. Chloride of silicon means silicon tetrachloride. So silicon tetrachloride reacts with cold water, 2 mole H2O to form silicon dioxide. Silicon dioxide SiO2 plus 4 mole of hydrogen chloride gas. Number 2, suggest the pH of this solution. As hydrochloric acid, so this is a strong acid, pH will be 1 to 4. 1 to 4, any value you can write, 1 or 2 or 3 or 4, any value you can write. Silicon tetrachloride reacts with water to form silicon dioxide and hydrochloric acid. Hydrochloric acid is strong acid, pH 2 or 3 you can write. Next, number C, an excess of cold water is added to the chloride of phosphorus. Chloride of phosphorus means phosphorus pentachloride. Write an equation for the reaction between cold water and chloride of phosphorus, means phosphorus pentachloride reacts with water to form hydrochloric acid and phosphoric acid, H3PO4. Hydrochloric acid is strong acid, phosphoric acid is a weak acid. So next, number 2, suggest the pH of this solution. Hydrochloric acid is strong acid, so pH will be 1 to 4. You can write 2 or 3 or 1 or 4, any value you can write, you get mark. D1. Write an equation for the reaction between chlorine and water. Chlorine reacts with water to form chloric 1 acid or hypochlorous acid, HOCl, chloric 1 acid plus hydrochloric acid, HCl. Now, number 2, write an equation for the reaction of chlorine with hot sodium hydroxide, hot alkali. You know, chlorine reacts with hot alkali to produce sodium chloride, sodium chlorate 5 and water. This is a disproportionation reaction, you know, same element simultaneously oxidize and reduce. Here chlorine oxidation number 0 as it is element. Here sodium chloride, chlorine is -1. Sodium chlorate, this chlorine oxidation number is +5. So chlorine reacts with sodium hydroxide to produce sodium chloride and sodium chlorate 5 and water. This is a disproportionation reaction because chlorine simultaneously reduced, it goes 0 to -1 reduce, and again it oxidize 0 to +5. So chlorine simultaneously oxidized and reduced. That's why this is a disproportionation reaction. Next, bleach is used as a cleaning product to kill bacteria. Now, identify the formula of the ion present in bleach that kills bacteria. Chlorate 1 ion, ClO minus. This name is chlorate 1 ion. Here chlorine oxidation number is +1. That's why its name chlorate 1. Number 2, sodium chlorate 1, NaClO, reacts with hydrogen peroxide, this is H2O2, to produce sodium chloride, water, and oxygen gas. Construct an equation for this reaction. This is the reaction. Number 3, a sample of bleach W contains an unknown concentration of sodium chlorate 1. 10 centimeter cube of W diluted with distilled water to make total volume 100 centimeter cube. That means 10 cm cube concentrated solution is diluted 100 centimeter cube. It has been diluted 10 times. From this solution, 25 centimeter cube dilute bleach solution is added to an excess hydrogen peroxide, and the volume of gas produced measured under room condition. The experiment is repeated, and on average 25 centimeter cube of diluted bleach solution produces 40 centimeter cube of gas. Now question is asking, calculate the concentration in gram per dm cube. You have to find out concentration in gram per dm cube of sodium chlorate 1 in W. So first, moles of oxygen, volume is given, so you will use gas formula. Mole of oxygen, volume of gas is 42 divided by molar volume, 24,000 centimeter cube. Molar volume of a gas, 24 dm cube or 24,000 centimeter cube. So you will get 1.75 into 10 to the power minus 3 mole. Now, mole of sodium chlorate in 10 centimeter cube concentrated or 100 centimeter cube diluted sample is 4 times, 4 into this mole, because this number of mole is calculated for 25 centimeter cube. So for dilute 100 is 4 times more. So 1.75 into 10 to the power 3 times 4 multiply by 4, you get moles of sodium chlorate 1. Now concentration. Concentration N equal number of mole equal concentration into volume. So concentration equal number of mole divided by volume. So concentration equal 0.007 divided by volume 10 divided by 1000. 10 is centimeter cube, so it needs to convert dm cube. That's why 10 divided by 1000. So you get 0.7 mole per dm cube. Now you know formula, concentration in gram per dm cube equal concentration in mole per dm cube into molar mass. Concentration in gram per dm cube equal concentration is mole per dm cube into molar mass. Sodium chlorate molar mass, sodium 23, chlorine 35.5, oxygen 16, 74.5. So 74.5 is the molar mass of sodium chlorate 1. So concentration of sodium chlorate in W 52.2 gram per dm cube. Next, question number 3. This is for organic chemistry. There is step 1, haloalkane, alkane nitrile, carboxylic acid and Y is unknown. A1, state the reagent and condition for step 1. Step 1, haloalkane to cyanoalkane, CN. In place of chlorine, product is cyanide. So reagent, potassium cyanide in ethanol and heat. Reagent and conditions. Reagent potassium cyanide, condition in ethanol and heat. Number 2, give the systematic name of X. X name, there are 3 carbon, you know. 1, 2, 3. CN, cyanide compound are known as nitrile compound. So this is propane nitrile. PROPANE NITRILE, propane nitrile, TRILE. Number 3, identify the type of reaction that occurs when dilute acid is added to X in step 2. Dilute acid means hydrolysis of cyanide compound. Hydrolysis of cyanide compound, CN group converted to COOH group. This is known as acid hydrolysis. Any CN group, if you acid hydrolysis, S plus means acid and water mix, if you hydrolysis, cyanide group converted to carboxyl group. This reaction is known as acid hydrolysis. So propane nitrile is converted to propanoic acid. This is acid hydrolysis reaction. Next, four, in step 3, Y and a gas are produced. Construct an equation for step 3. Propanoic acid, this is carboxylic acid, reacts with metal to form calcium propanoate and gas is hydrogen. You know, any carboxylic acid reacts with metal to produce metal salt of carboxylic acid plus hydrogen. Metal salt of carboxylic acid plus hydrogen. Carboxylic acid, 3 carbon propanoic acid reacts with calcium to produce calcium propanoate plus hydrogen. This reaction you will observe fizzing occurs, hydrogen gas or bubbles of gas, effervescence. Also you can observe solid calcium dissolve. disappears. This will be 2 observation. Number B, propanoic acid can also be formed from propan 1-ol. Propan 1-ol is a primary alcohol. Primary alcohol goes to carboxylic acid and potassium dichromate. State the condition required. Potassium dichromate, acidified potassium dichromate. So acid is needed, and heat under reflux. That means heat in a closed system, heat under reflux is a one heating apparatus. Now number C, complete the following table to show the number of sigma bond, sigma and pi, sigma bond and pi bond present in molecule of X. X is, you know what is X? X is alkane nitrile. So 3 carbon, propane nitrile. This is the displayed formula of propane nitrile, carbon nitrogen triple bond. Now this carbon has 4 bond, nitrogen 3 valency, every carbon 1, 2, 3, 4, this carbon 1, 2, 3, 4. So question is asking how many sigma bond? Single bond all are sigma. In triple bond, one is sigma, another 2 is pi bond. So here pi bond number is 2 and sigma bond 1, 2, 3, 4, 5, 6, 7, here 1, 8. 8 sigma bond and 2 pi bond. You know, single bond all are sigma. In double bond, one is sigma, another is pi. And triple bond, one is sigma, 2 is pi bond. Now we'll go next question. 4. This ethene reacts with steam to produce ethanol in presence of phosphoric acid catalyst. So this bond energy or bond enthalpy, bond is given and bond energy values or bond enthalpy values are given. So question is asking calculate the enthalpy change delta is R. Enthalpy of the reaction calculate, delta is R, you have to calculate. You know, left hand side this displayed formula I write ethene and water, this is the reactants, ethanol is the product. You know, in reactant bonds are broken, in product bonds are formed. So you will count bonds broken 610, 1 carbon double bond in ethene, and 410 there are 4 CH bond, 460 2 OH bond, you see here, 1 OH, 2 OH, oxygen hydrogen bond 2, so 2 into multiply that. Now in product there is 1 carbon carbon single bond and carbon hydrogen bond 1, 2, 3, 4, 5, carbon oxygen bond 1, oxygen hydrogen bond 1, so you have to all add. Bonds made or bonds formed, this all you have to add, you get this 3220 kilojoule. Bonds broken 3170 kilojoule. So enthalpy change delta H R equal bond broken energy, I mean reactant total energy, bond form energy or bond made energy, you get negative 50 kilojoule per mole. So this is an exothermic reaction as delta HR is negative value. Number B, reaction 1 reaches equilibrium at constant temperature and pressure. Deduce what effect increasing the pressure will have on the amount of ethanol in the new equilibrium mixture. Effect of increasing pressure, you know, if you increase pressure, equilibrium will go to the lower number of moles, smaller number of moles. You see the equation, product has only 1 mole, reactant has 2 mole. So if you increase pressure, equilibrium will move from left to right, I mean ethanol increases, amount of ethanol will be increases because equilibrium will move from left to right as there are less number of molecules on right hand side. Now you see the answer. Effect of increasing pressure, amount of ethanol increases. Explanation, equilibrium moves to the right to produce fewer moles of gas. If you pressure increase, to produce fewer moles to reduce the pressure. This is, you see, mechanism 1. This oxygen is more electronegative, so oxygen is attracting electron, hydrogen become positive, pi bond gives electron to positive hydrogen. So this oxygen become negative, nucleophile, and ethene form positive carbon, so electrophile. Step 2, this positive electrophile water lone pair gives electron to the electrophile and this positive species is formed. Now you see question is asking what? Describe the behavior of phosphoric acid in a step 1. Explain your answer. You see step 1, phosphoric acid, what happened? Phosphoric acid become negative ion. It lose 1 hydrogen. That means phosphoric acid work as acid because acid donates proton. Acid is a proton donor. So answer will be acid as it donates a proton. Now number 2, identify the species that behave as electrophile in step 2. Explain your answer. Electrophile means positive something which seek out negative center. So step 2, which is species is positive center? positive species is this. That's why negative oxygen attract the positive one. So in step 2, CH3CH2 plus works as an electrophile as it accepts a pair of electrons. Electrophile always accept a pair of electrons. Nucleophile always donate a pair of electrons. Now number 3, complete this figure to show the mechanism for step 3 of reaction 1. Include charges, dipoles, lone pairs and electrons and Carli as appropriate. You see, product is ethanol. So here there are 2 hydrogen, 1 hydrogen have to lose. So oxygen is positive, this bonding electron go to the oxygen. So positive oxygen become neutral, and this nucleophile gives electron to H plus. Phosphoric acid is again reform. That means phosphoric acid works as a catalyst here. This oxygen takes electron, so oxygen positive become neutral, hydrogen become H plus. This oxygen negative ion, it has a lone pair of electron. This oxygen gives electron to the H plus, so minus oxygen plus hydrogen it becomes neutral. Describe how a catalyst affect a reaction. Explain your answer. You know, a catalyst increases the rate of reaction by producing an alternative reaction pathway with lower activation energy. Or you can write, a catalyst provides an alternative route with lower activation energy. 5. In figure 4.1.4.2 to justify why phosphoric acid is described as catalyst in reaction 1, because phosphoric acid is regenerated, that means it is reformed, is produced again at the last of the reaction, it is again reformed. Now 6. Propene also reacts with steam. A mixture of organic product is produced. Explain why propan-2-ol is produced in the higher yield. More stable carbocation due to positive inductive effect of more alkyl group. I mean, propan-1-ol CH3 H, this positive carbon. Propan-2-ol is form of the higher yield because positive carbon is attached to other methyl group 1, 2. So this intermediate is more stable due to the positive effect of alkyl group. Here 2 alkyl group, but propan-1-ol carbonium ion has 1 alkyl group. So that's why this carbonium ion is more stable. For this reason, propan-2-ol is the major product. More yield, more product you will get. So answer will be more stable carbocation is formed due to the positive inductive effect of more alkyl group. Describe the covalent bond present between carbon atom in ethene molecule. Ethene CH2 double bond CH2. So sigma bond double bond sp2 hybridization. Type of orbitals involve sp2 double bond always sp2 and pi bond 2p orbital. p orbital sideways overlap to form pi bond, and sigma bond is formed by the head on overlap or direct overlap. Pi bond is a sideways, sigma bond is head on overlap or direct overlap. Next question 5. Describe structural isomerism. Molecules with the same molecular formula but different structural formula. This is known as structural isomerism. Structural isomer. Same molecular formula but different structural formula or different discrete formula. Now you see A and B are structural isomers with molecular formula C5H10O, 5 carbon, 10 hydrogen, 1 oxygen. There are both state molecule with only one functional group. There is only one functional group. So reagent and their reaction A and B. 2,4-dinitrophenyl hydrazine 2,4-DNPS reagent, orange precipitate appears. That means it may be aldehyde or ketone, carbonyl compound. Orange precipitate appears. B also aldehyde or ketone, carbonyl compound. Tollens reagent, silver mirror, so A will be aldehyde because aldehyde give positive test with Tollens reagent. No reaction, that means B is not aldehyde. Alkaline iodine, iodoform test, no reaction, that means this is not methyl ketone or not secondary alcohol. B also, that no reaction with aqueous iodine. Now see the A is aldehyde, one, 2, 3, 4, 5 pentanal. So it reacts with aldehyde, reacts with 2,4-dinitrophenyl hydrazine, reacts with Tollens reagent, but this aldehyde don't react with aqueous iodine, iodoform test. Now B, orange precipitate with 2,4-dinitrophenyl hydrazine, that means this is a carbonyl compound. So this is 1, 2, 3, 4, 5, 3 pentanone. Tollens reagent ketone does not give this test, and alkaline iodine ketone 3 pentanone does not give this test, but iodoform test alkaline iodine reacts with only methyl ketone CH3 CO. This compound will give iodoform test, but this no reaction. That means B is not methyl ketone. So this is not methyl ketone. This is this CH3 CH2. This is the ethyl ketone. That's why compound B does not give positive test with alkaline iodine. Now next question. C is a structural isomers of A and B. C is a straight chain and has two functional groups. C shows only one type of stereoisomerism. There are some reagent for C. Here 2,4-dinitramyl hydrazine, no reaction. That means it is not aldehyde, not ketone, not carbonyl group. It has no carbonyl group. Bromine, aqueous bromine, orange to colorless. That means it has carbon-carbon double bond, because bromine water decolorizes alkene molecule. Aqueous iodine, yellow precipitate is formed, so it is secondary alcohol. Secondary alcohol gives iodoform test. So this secondary alcohol group CH3, here one hydrogen. This is a secondary alcohol. And also bromine water, from this part bromine water turns orange to colorless. From secondary alcohol it reacts with alkaline iodine to give yellow precipitate. Name the type of stereoisomerism shown by molecule C. Optical. Why optical? You see, this is a chiral center here. This carbon is chiral because here there is one hydrogen here. So it will show optical isomerism. But this will not show geometric isomer, because this is CH2, one double bonded carbon contains same group, I mean two hydrogen. That's why it only show optical isomer. You see, D reacts in the presence of sulfuric acid. D reacts in the presence of sulfuric acid to form ester. You know, ester is formed by the alcohol and carboxyl group. OH group and COOH group to produce ester. So E is a ester, functional group have, this is. Now number 2, identify the type of reaction that occur when D reacts with the condensation reaction. Two different type of functional group when react, this is condensation reaction. Now draw the structure of D. D, you see, D reacts with sulfuric acid, this star, this breakdown here, so O will be alcohol, you break down this, oxygen, hydrogen will be added here. Here CO, one OH group, because carboxyl acid lost OH group and alcohol lost hydrogen. water will be formed, and also you will get D, monomer. So you see here this O is OH, you add here OH, then CH2, 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 CH2. After that, this carbon oxygen double bond carbonyl group, and also it has lost OH group, so you have to monomer, you have to add OH group. Simply just when you form monomer, here oxygen hydrogen will be added, here CO OH will be added. That's why this is the D structure. Now you see this is an IR spectra. This is most sharp peak, this and this. This inverted spectra of E. E means is this compound, so it has CO peak, carbon oxygen carbonyl group peak, and D has carboxyl OH peak and carboxyl CO peak and alcohol OH peak. So you see now this their wave number ray values is given. So now you question is asking you any two, you write figure 5.2 and 5.3 predict two differences in the absorption above 1500 per centimeter of the infrared D compared to E. D and E will compare. You see E is a star, CO star group, it will give a peak this 17102 1750. Carbon oxygen double bond star, this value is given. And D carbonyl group, carbon oxygen double bond will give peak this range 16702 1740. Carboxyl CO, this range carboxyl. Then D alcohol, OH carboxyl group, carboxylic acid OH group will give this value 2500 to 3000. So OX carboxylic acid OH group will give this value 2500 to 3000, and if OH alcohol group, that will range different 3200 to 3600. So OH carboxyl group one peak range this, এবং OH hydroxyl group this range. Both are present in diagram, you see here CO and OH. Thank you. Please subscribe, like and share my channel.